This is the introduction to exercise 7D and exercise 7E on functionation and identities, and also families of functions and solving literal equations on page 322 and 324 of your textbook. Now, functionation and identities. Identities just means certain formulas that we're quite familiar with, and functionation, of course, we're just trying to make sure that we're all on the same page regarding how to write certain equations. So in this situation, please note that in general, if we have f of x plus y, it is not the same as f of x plus f of y. In fact, f of x plus y in brackets means that we're substituting x plus y into the function. So it's not the same as adding them together, but it can be. Sometimes it is, but it's very rarely. So we say generally that's the case. Same idea applies. Generally, f of x, y, in brackets, is not the same as f of x times by f of y. So they're two different identities. So if we're putting the practice, it's pretty straightforward. You guys have actually already completed a practice exam question on this. For the function, with the rule f of x equals to 2x, show that f of x plus y equals f of x plus f of y for all x and y. All we have to do is prove they're the same thing. And to do that, you could take a couple of pathways, but I think the easiest one is to just substitute x plus y into our function and see if it ends up being the same as f of x plus f of y, sorry. So for part A, I'm going to write f of x plus y equals, and I'm going to write this function, but it's substitute x plus y instead of 2. So that's 2x plus y, which we know expands out to 2x plus 2y. Pretty straightforward. Any questions? No? Okay. And then we'll do the same thing. We'll do f of x plus f of y, which equals to 2x plus, and then f of y is just, I'm just substituting y instead of x, so that's 2y. Now, if I'm going to write it mathematically, I'd say f of x plus, f of x plus y, equals to f of x plus f of y, and I'm going to put a therefore at the start. So therefore, f of x plus y equals f of x plus f of y. You've demonstrated a logical process. You've gone, this is what f of x plus y is, this is what f of x and plus f of y is. They're the same thing, therefore they are the same thing. Okay, any questions? I'm going to leave question B for you guys to complete yourself. It is the same idea, except in this situation, we're trying to prove that they're not identical. And you apply the same logic. You find f of x plus y, see what you get, and then you find f of x, and then you add f of y, add them together, and show that they're not the same. And then you say, therefore, this is not equal to this. Great. Moving on to content from exercise 7E. Again, it's stuff that you guys already know. The only additional thing is that there are literal equations in this situation. So literal equations, quick reminder, means that we're working with an answer or a response that does not have all constant terms. They might perhaps have pronumerals in them. So, as per usual, we extract the information we know from an equation including, and it could be in the form of coordinates, intercepts, stationary points, asymptotes. That one seems to miss a lot of students for some reason, and gradients and whatever other information you can get. The only additional note, is to leave your response in terms of a specified variable. So in these situations, it might say, find the equation of this graph in terms of C, or in terms of whatever it is. You just leave it in that format. It's perfectly fine. In this example, the graph of a quadratic function passes through the points 1, 6, and 2, 4. So again, stuff that we're already very familiar with. Find the coefficients of the quadratic rule in terms of C, the y-axis intercept of the graph. So it says in terms of C, which means you have to use the letter C. And we also know that C is specified in the question as a y-axis intercept. Now I'm going to write the generic rule, so y equals to ax squared plus bx plus c. Can you read that up the back? Lovely. Okay. Do we agree that this has coefficients of in the form of pronumerals that we don't know? Yeah. We also agree that the c is a y-axis intercept. So we've been given the information there. Then all we do is what we're very familiar with. We substitute the points. So I'm going to sub 1, 6, where we get 6 equals to a times 1 squared, which is just a, plus b plus c. And the other one, I guess, if I substitute 2, 4, 4 equals to 4a plus 2b plus c. Any questions about that? No? Okay. If you're using the calculator, you could then put this in the calculator, do simultaneous equations, and just find it in terms of c. It'll spit out an answer in terms of c. That's perfectly fine. If you're doing this by hand, we do the same thing. But I'm going to put this in the calculator. Actually, you know what? I'll just write out the answer. So putting this in the calculator or solving it by hand gives you an answer of a equals to c minus 8 over 2. Of course, you can write it as two separate fractions if you'd like. And b equals to 20 minus 3c over 2. Have I answered the question? Do I need to write out the whole equation? No, not really. It just says find the coefficients. We've specified, to be fair, I should have written let y equal blah blah blah, but we specified a equals that, b equals that, and we've done it in terms of c, so I'm happy with that. If you're not sure, you can write out the whole equation as well if you'd like. Great. Let's move on to this question here. Sorry? No, it says find the coefficients of the quadratic. Yeah. No, that's fine. In terms of c, the y-axis and stuff. The wording's a bit weird, but I get your point. So we've found all the a and b coefficients in terms of the y-axis intercept, which is c. Transformations. This one, historically, both this year and in previous years, has been answered very, very poorly. So definitely work with the transformations as much as you can. A transformation, t r squared to r squared is defined as the matrix below. We've got this right here, this matrix, where k is a non-zero real number. Find x and y in terms of x dash, y dash. Of course, this means that we need to be able to use our multiplication of matrices. Apologies. Multiplication of matrices, which means we have 5x plus 0y plus 5 equals to x dash. Any qualms with that? Okay. And then we also have 0x plus ky plus 2 equals to y dash, which of course simplifies to 5x plus 5 equals to x dash, and we also have ky plus 2 equals to y dash. Now, of course, we need to actually find x and y in terms of x dash, y dash. So rearranging that, I probably should have left more space, gives us 5x equals to x dash minus 5, and then x equals to 1 over 5 x dash minus 1. And y equation, we have ky equals to y dash minus 2, which means that y equals to 1 over ky dash minus 2 over k. Any questions? Okay. Move on to question B. It says find the image of the curve with the equation y equals to 1 over x under this transformation. If we're trying to find the image, do I want y dash in it or do I want x in it? This is kind of drawing from a couple of weeks ago. Good, x dash, y dash, because that represents the image. If I've asked you for the transformations involved, then you want to use the x values or the y values. But let's use y dash. So I'm going to rewrite, because it says this is the equation, isn't it? Y equals 1 over x. So I'm going to rewrite y equals 1 over x using my defined values of y. So in this case, we said that y is this. I'm actually going to write it as equals to y dash minus 2 over k. Same thing, I'm just making it a little bit easy for us to interpret. So we end up with y being replaced with that. So that's y dash minus 2 over k equals 1 over, and then x is going to be 1 over 5 x dash minus 1. That comes from over here. Okay. Any questions? No? Okay. Would you agree that this is the same as 1 over x dash minus 5 over 5? Same thing? Yeah. Okay, great. With that in mind, I'm going to flip that. I'm going to work with the division. I'm skipping a couple of steps, by the way, but this will end up with 5 over x dash minus 5. Are we still okay with that? Great. I'm just going to rewrite this part over here. Y dash minus 2 over k. Now, in order to get y by itself, or y dash, the image, I need to multiply both sides by k, so that's y dash minus 2 equals to 5k over x dash minus 5. And then I'm going to plus 2 on both sides. You know what? I'm not going to rewrite it. I'm just going to write that here. So that's y dash equals to 5k over x dash minus 5 plus 2. And then finally, as an answer, I would write image y equals to 5k over x minus 5 plus 2. Whew, that's a lot of work. Last question. Find the value of k if the image passes through the origin. If it passes through the origin, what does that mean? Good. C, here we go. Alright, so if it passes through the origin, 0, 0, that means we have 0 equals to 5 times k over 0 minus 5 plus 2, which means that we have 0 equals to 5k over negative 5 plus 2. Hopefully I'm not going too quickly. 0 equals to negative k plus 2, which means that, therefore, k equals to 2. Long question, but just applying understanding of transformations, understanding of polynomials as well. Any questions? No? Okay.